This figure illustrates the hypothalamic pituitary gonadal axis. Prior to puberty, estrogen levels in the blood are low. These low levels of estrogen prevent the hypothalamus from releasing gonadotropin-releasing hormone. At puberty, if leptin levels in the blood are high enough, the hypothalamus will become insensitive to the low levels of estrogen and release gonadotropin-releasing hormone. Leptin is released by adipocytes. The amount of leptin reflects the amount of triglycerides stored within the adipocytes. Females that have low levels of adipose tissue will not release enough leptin, and this may delay the onset of puberty. In response to leptin, the hypothalamus releases gonadotropin-releasing hormone. This, in turn, causes the release of FSH and LH. After puberty is initiated, it will take an additional 4 years before a female has her first menstrual cycle. Let's follow what FSH and LH do. The target for LH are the interna theca cells. Remember the theca interna. These cells take cholesterol from the blood and convert them into androgens. The androgens then will be taken up by the granulosa cells. The granulosa cells will have receptors for FSH. The FSH will stimulate the granulosa cells to convert the androgens into estrogens. As the androgens are converted into estrogens in response to FSH, estrogen levels will increase. In addition, granulosa cells also release inhibin. Elevated levels of estrogen and inhibin inhibit the release of FSH from the anterior pituitary.
It is believed that the dominant vesicular follicle
Has increased numbers of FSH receptors. The levels of FSH at this point are low, and therefore that dominant vesicular follicle can take advantage of the increased numbers of FSH receptors. The other follicles will not survive. As the dominant follicle continues to mature, estrogen levels will be increased. When estrogen levels increase to a certain point, those levels will function in a positive feedback mechanism to stimulate the release of gonadotropin-releasing hormone and LH. A surge in LH in the plasma triggers the oocyte within the dominant vesicular follicle to complete meiosis I, giving rise to a secondary oocyte and a polar body. The secondary oocyte begins meiosis II but does not complete it. Ovulation occurs, and the secondary oocyte with the zona pellucida and corona radiata are released from the ovary. Therefore, there are two events that occur in response to the surge in LH. The primary oocyte completes meiosis I, giving rise to a secondary oocyte that begins meiosis II, and ovulation occurs. Let's go through the hormonal regulation of the ovarian cycle one more time. Recall that it involves the hypothalamic pituitary gonadal axis. Gonadotropin-releasing hormone released by the hypothalamus at puberty will go to the anterior pituitary and cause the release of LH and FSH. Prior to puberty, low levels of estrogen will inhibit the release of gonadotropin-releasing hormone. At puberty, if levels of leptin are high enough in the plasma, the hypothalamus will become insensitive to the low levels of estrogen and release gonadotropin-releasing hormone. Be sure that you understand the relationship between leptin and the release of gonadotropin-releasing hormone. In response to gonadotropin-releasing hormone, LH is released. LH will bind to the theca interna cells. Those cells then will take up cholesterol and convert them into androgens. FSH will go to the granulosa cells and stimulate them to take the androgens and convert them into estrogens. You need to know which cells have receptors for which hormone and what happens in response to the hormones. Recall that increased levels of estrogen and inhibin through a negative feedback mechanism will decrease the release of follicle-stimulating hormone. The dominant vesicular follicle will survive and continues to release estrogen. Estrogen levels will be elevated, and as the estrogen levels become elevated, they will bring about a positive feedback mechanism that increases the release of LH, thus leading to a surge in plasma levels of LH. It is this surge of LH that will stimulate the primary oocyte to complete meiosis 1, divide, and give rise to a secondary oocyte and a polar body. Recall that the polar body is not viable and usually disintegrates. The secondary oocyte begins meiosis 2, but stops in meiosis 2. It is not completed. During ovulation, the secondary oocyte arrested in meiosis 2, the zona pellucida and the corona radiata are released from the vesicular follicle. What remains of the vesicular follicle becomes the corpus luteum. Keep in mind that it is a surge in LH that triggers the primary oocyte to complete meiosis 1 and begin meiosis 2, as well as ovulation. After ovulation, estrogen levels begin to drop. However, when the corpus luteum forms, progesterone, estrogen, and inhibin are released. Progesterone helps maintain pregnancy. Elevated levels of estrogen and inhibin will inhibit the release of gonadotropin-releasing hormone. This, in turn, will decrease the levels of luteinizing hormone. This will prevent another group of primordial follicles from beginning the maturation process.